First, a little bit of history. I actually started my career in this industry over 30 years ago in these very buildings. More precisely about 100 yards east of here in an advanced development group in digital software engineering. This building was the hub of digital software engineering in the early 80s. The actual buildings that we're in were built successively from what was called ZK1 to ZK2, and then this building here was ZK3. Where Plexxi is, it was actually the Unix group at DEC. Upstairs was the VMS operating system group where I spent most of my time here at Digital. I was a VMS operating system developer. These buildings, how do we advance the slide? These buildings were built in the first era of computing, often called by IDC Platform 1, mainframe and mini computer. Sadly, these buildings emptied in Platform 2, client-server era. In Platform 2, there was the emergence of a whole new set of companies. Cisco, one of them, right? Oracle. There was a decomposition of the infrastructure into its building blocks. And the nature of the infrastructure evolved from mainframes and mini computers to client-server multi-tiered architectures. And that is the world that we've lived in for 20 years. And now we're facing a time of the third era of computing, or Platform 3 era, or in Gartner jargon, Mode 2 modalities. And if you think about, Platform 2 architectures, they were multi-tiered. You had clients, you had a LAN, you had a server, you had your SAN, you had your storage array, and you had your disks. And that's how we've built the infrastructure for 20 years. And in the Platform 3 era, everything about the infrastructure is changing. If you think about the network as one of the fundamental building blocks of IT, the networking architecture hasn't changed for 20 years when these buildings were evacuated. In fact, when we moved into these buildings, it was like a neutron bomb went off because there were cubicles emptied with digital VMS and Unix manuals on the shelves. It was that pathetic. Some of you are nodding, you remember this, okay? But everything about the applications have changed. For 20 years, we've built the infrastructure and we've said, well, we're deploying our ERP and we have 10,000 users and our business is growing at 5%, 6%, 7%. And so what we're going to do is we're going to deploy it, we're going to buy our infrastructure for the next 5 years ahead of time, a priori, design it, deploy it, and then slowly pour our applications and data into our infrastructure. And in this era, in this new era, all of that has to be thrown out the window. Why is that? Because the very nature of applications and data have fundamentally changed. Today, we start with petabytes as our starting point for data. You're not moving petabytes around. Every application has either been rewritten or is being rewritten to be scaled out. Well, there are lots of reasons for that. It's not just cost, it's agility. And so these scaled out applications are growing extremely rapidly because if you have a web-facing app, you don't know if you can have 100, 1,000, 10,000, a million, 10 million, a billion users. So what this says is, and this is the fundamental problem that Plexxi addresses, what this says is we need to build an infrastructure, not first, not a priori, but we need to build infrastructure that can be shaped around the data and the applications, because you're not moving it. And it's scaling in ways we had never contemplated 20 years ago. So you have a simple choice. You can build the future infrastructure using components that were built 20 years ago and have the same capital expense and operating expense and add more and more complexity to your infrastructure. Or you can have a new approach. Build your infrastructure on a new network architecture, a network architecture born in this era, not 20 years ago. In this era, automation, DevOps, are the fundamental value propositions, our highest form of the value propositions. It's not about line rate and 10 gig and 100 gig. It's not about that. That's the easy part. We can cable things together. In fact, we have way too many cables, and you'll see some of the benefits of our architecture there. It's about the applications and the data and compute scaling out, not up. Having an infrastructure that's dynamic in that way. The infrastructure can no longer be defined a priori. There's no way you can define the infrastructure of the future a priori. And so you need an architecture that will allow you to do this. An architecture that's not defined by its cables, but defined by software. We try to stay away from the word SDN because it's been so diluted. Often I'll describe it as NDS, a network that can be defined by software. A network that understands your workflow and is designed around your workflow. A network that understands your application, Hortonworks, Cloudera, and understands which nodes are in those environments. Understands that you're in a VMware environment and these nodes are in a cluster. Understanding that you have clustered ONTAP and all of your storage traffic is on your IP network, or vSAN, or Scale.io. So if you step back and think about Plexxi for a moment and don't paint us into the box of we're a network. Think about us as a modern way to connect compute and storage resources that's under software control. Think about us as that. A way to connect storage and compute resources under software control. And then think about what's happening in converged infrastructure, right? It turns out that when you go from the platform 2 design of client, LAN, server, SAN, storage array, disk, to converged infrastructure, the first and most fundamental step everyone makes is they eliminate their fiber channel SAN. Now remember where I worked last. Okay?
Well, that's why you don't work there anymore, right?
So, you know, by the way, even there, more than half of my volume was in iSCSI at the time. So you should know that this trend has been going on for a long time. But the bottom line is that when you go to converged infrastructure, the separate technology stovepipes goes away. And so now you eliminate your SAN. So now all of a sudden you have all of the traffic that is predominantly east-west onto your network that was designed 20 years ago for north-south traffic. And you have many different data types that are extremely latency sensitive, all dropped onto this one network. And so you don't need a network that's defined by its cables statically. You need a network that's defined by software and truly dynamic. And so what you'll hear for the rest of the day is this one idea talked about in several ways. And we got a lot of validation for this this week at the .next conference in Nutanix. Nutanix is clearly one of the most rapidly growing converged infrastructure players, and our relationship with them, you know, is evolving very rapidly. But they're just one example of people facing this problem. If you look at Scale.io, if you look at vSAN, if you look at Hortonworks or Cloudera on existing networks, if you look at clustered ONTAP, they all have exactly the same challenges. And the solution to these problems today is to deploy more and more separate and discrete physical networks. How many times do you want to deploy networks? How many different networks do you want to control? So at the end of the day, what Plexxi allows us to do is to build private clouds in a new way, reducing your capital expense significantly and reducing your operating expense by having a new network architecture, a network architecture born in this era, totally controlled by software, creating an agile and very flexible alternative to the public cloud. So again, thank you guys for coming out. My team's at your disposal here. You have a lot of our engineers. They're all down the hall. Go as deep as you like. They're engineers, right? So if they don't know, they'll say they don't know. So be nice to them because we don't let them out in the light very often. So you guys are getting unique time to spend with them. Those are my initial remarks and spend time with the team. Any quick questions, or I'm sure you'll have tons, or I'll just exit stage left and let you get to it. Sure.
How are you doing just from a business point of view in terms of customers and sales and that kind of?
It's a great question. So you're mic'd, so I don't need to repeat the question, right? Yeah, okay. So this is our second year of real revenue growth. We had a substantial revenue year last year where we haven't really disclosed these things publicly. And this year we expect to grow by a multiple of that. So we're very encouraged by that. How do we do it? Is really two ways. One way is we are recruiting partners that are aimed at these very use cases of converged infrastructure, like recruiting Nutanix partners, for example, and fly after them with people that have these pain points. So we look for partners who see their customers transitioning away from fiber channel SANs, okay, heavily virtualized environments, and we recruit those partners, and we go sell to those customers with them. They understand the opportunities, and they have established relationships. That's one modality. We spend a lot of time with OEMs, and we hope to embed our technology in some OEM solutions and allow them to build these kind of next generation networks for converged infrastructure and storage systems. And so
are there any OEM people you can mention? Or?
I can't mention any of them. And even if I had all the deals signed, I still couldn't tell you that. So that's really their prerogative to talk about. But we've had various engagements at various levels, some pretty advanced and some more nascent. But
so is the kind of solution you're hoping to get into in these partnerships, if you think of FlexPod and VCE, that Plexxi would replace the Cisco component of that?
So think about it a little differently, right? So if you think of us more as a next generation SAN and less as a network alternative, then it's probably more conceptual. Think about us replacing Brocade. Okay? Think about us replacing Brocade. Because conceptually, we're really aimed at storage and compute scaled out infrastructure. And the component, that might have been a backplane 20 years ago, but think about it now as a very elastic fabric that you can put storage and compute on. The Cisco infrastructure would probably stay in place.
Yeah, but you're still talking about carrying all the east-west traffic.
Yes.
Okay.
Just like a SAN.
Yeah, so
the analogy to SAN is actually not that far off.
Well, it's the data center LAN, not the campus LAN.
You'll probably still have your data center LAN because you have to connect everything to everything. We're not necessarily going after the port game, right? We're going after the hyper-converged infrastructure, the big data environment, right? And I'm sure the guys will cover this. I mean, one use case for us is you take a few of our switches into an existing 752 or 753 architecture, and you expand your big data environment, in this case, Hortonworks environment, on these 6 switches, and that becomes your big data network that's adjunct to your existing network. You grow in that way. Cisco would say, just install another one of my networks. We'll just take the storage. We'll take the storage piece of that network. It's really almost the convergence of a SAN and a LAN.
But then if companies are wanting to converge their networks, particularly with something like vBlocks and obviously with a hyper-converged, people are moving away from having a dedicated SAN switching fabric and running either fiber channel over Ethernet or purely 10 gig NFS Ethernet networks. But the point being they're running their storage networks and their east-west data center networks on the same fabric.
So
we've got a demo for you.
That's the first generation, I would say. So if you think about, there's clearly a need for fanning out to connect all your client. Think of it as client.
Yeah, that is a different.
That's the land of Cisco, right? We're the data center fabric. We're the compute and storage fabric. It happens to be IP based and it has a lot of the same properties, but it has this programmability and agility that's really tuned to those applications.
You're saying, so the first phase is bringing these networks together to avoid having to have a separate SAN network for fiber channel, for example. But with the explosion of data, with things like hyper-converged for the replication part and big data, you're seeing that converging the LAN traffic and the storage traffic may not be enough, and so we're going to, in a way, swing back to having a storage network to support big data and hyper-converged.
It's really it's a multi-purpose network, right? So it is a converged network from that perspective. So these were great single-purpose networks, these fiber channels, InfiniBand, all that, they were optimized, designed for specific types of workloads, right?
Yep.
Ethernet's a great general purpose network, right? But what we see now is as people try and put more and more stuff on that you now need, you essentially need the cost dynamics of this with the ability to isolate and segregate traffic that has specific workload requirements like storage, right? But it is converged.
So we have one customer that's deployed us now. It's kind of a weird environment. During most of the day, it's mostly VDI, and during most of the night, it's mostly analytics. So it's mostly north-south during the day, some east-west, but mostly east-west at night with some north-south. You could separate these separate networks out, or you could build one network that could do either or both of those simultaneously. That's the essence of what Plexxi solves.
Okay. Yeah, that was just my slight concern that if you're painting yourself into we're a brocade, fiber channel SAN replacement.
I got your point.
That's good.
I tried to make the contrast. I tried to drag you into the SAN to change the focal point away from we connect all the clients together in your network.
Yeah, no, you definitely a data center network. Forget
you got it.
Yeah.
You got it.
No, thanks.